Let's take a look at another derivative example. Suppose I'm given the function y equals negative 2 over a polynomial. Let's have x squared minus 3x minus 4 all squared. Let's think about this function a little bit first so that we have some expectations about it. I see that this denominator could be factored. This quadratic looks like it factors into x minus 4 times x plus 1. So I have a product of negative 4 here and a difference of negative 3 between these two constants, and that whole thing is getting squared in the denominator. So the two values that would make this 0 are positive 4 or negative 1. And if I have those zeros in the denominator, I expect that I'm going to have some spiky behavior in my derivative. So let's take a look at a graph of this. Here we have it in Desmos. I see negative 2 over our polynomial squared, and indeed we have spikes down toward negative infinity at positive 4 and negative 1 as expected. What technique do we use to take this kind of derivative? Well, I see that I'm taking a polynomial times a constant and raising it to, I'll say, a negative power. So let's begin by rewriting this function in a form that's a little bit easier to work with. I have negative 2 times x squared minus 3x minus 4, and that is all raised to the negative 2. So what are the two parts of that function? I like to describe this negative 2 as being just along for the ride. It's a multiplier, and we don't need to worry about it. But now we have an outer function. My outer function is going to be this part, raising to the negative 2 power, and my inner part will be x squared minus 3x minus 4. To find y prime, we're first going to apply the power rule to the outside. So bringing this negative 2 down, negative 2 times negative 2 is negative 4. Before I fill in the guts, I like to deal with the exponent. I'm lowering it by 1, so that's becoming negative 3. Remember, it's becoming 1 less negative, not 1 closer to 1. The inside happens in what way? It stays the same. And now we multiply by the derivative of the inside. That is what the chain rule tells us to do. 2x minus 3. So there's our derivative. Let's take a look at that and make sure that it makes sense in relationship to our graph. So here we have the graph. Looking at the original function, we see that it has a very slightly negative slope that then becomes extremely negative, then extremely positive. Let's take a look at the derivative. And I see that I forgot that minus times minus is a plus. So I see that this is negative, becoming much more negative, and then the slope of the red function is indeed extremely positive, and it's coming back down here to 0. So this is looking correct with a positive 4. And that is why we check with the graph, because we can catch mistakes like that.